Science today is a reading. I will snap my finger and please read the word along with me. Let's give it a try. Edison sees the light. The filament burns out too quickly, Mr. Edison said. We have to find a better material to make a longer lasting filament. Thomas Edison, 1847 to 1931, was the most famous inventor of his time. He invented the phonograph, the motion picture camera, the first copy machine, and hundreds of other things. He is most famous, however, for improving a product he didn't invent, the electric light bulb. The problem with light bulbs before 1879 was that they burned out too quickly. The filament is the part of the light bulb that actually makes the light. When an electric current flows through the filament gets so hot that it glows and gives off light. The hotter the filament gets, the brighter the light, but the hotter the filament gets, the faster it burns out. Over here you can see a lovely photo of Mr. Edison with his giant light bulb. And what was so special about filaments back in the day? Those filaments, they burnt out quickly. Moving on to the next page. This is a long one. Get ready. So over here, Edison's short-lived light bulb was a simple device. It was much like a modern incandescent light bulb. In an incandescent light bulb, two stiff support wires hold the filament. A clear glass globe surrounds the filament for protection. The glass globe is attached to a metal casing. The tricky part is how the support wires, which are part of the circuit, connect to the metal casing. One support wire attaches to the side of the metal case. The other support wire attaches to a small metal disc at the bottom of the base. The base contact point must not touch the main part of the metal case. This is important. When electricity travels to the light bulb in a circuit, the electricity must flow through the filament. When you put a light bulb in a circuit, electricity can be delivered to the light bulb. When the circuit is complete, the electric current will flow. The electric current has energy. The energy produces heat and light as the light bulb does its job. Energy leaves the light bulb system as light. Edison tackled the filament problem with hard work. He is credited with saying, "Invention is 1% inspiration and 99% perspiration." Perspiration is sweat, in case you didn't know. I think this is a pretty funny line, but anyways. Edison directed his team to try every imaginable material to find the best filament. It is said that they tried and rejected 2,000 materials. Edison needed help. So here's an example of an electric circuit. This is like what we studied in class. Here's the positive terminal and the negative terminal of the battery, also known as the D cell, connected by two wires. You can see how one is at the bottom of the light bulb and one is at the side, like we figured out in class. And here's the filament that is being spoken of. If you have a light bulb in your house, you could take a look at it as well. Okay, moving on to the next page. There's only 3 pages to go. Help came in the form of Louis Latimer, 1848 to 1928. Latimer was an experienced draftsman and inventor. He had been working on the filament problem too. Latimer discovered that a carbon-coated cotton thread made a good filament. He got a patent for the carbon filament. Inventors get patents from the government when they invent something new. When Edison tried the carbon filament in his lab, he agreed that it was the best material. Edison bought the patent from Latimer. Now Edison could use the carbon filament in his light bulb. Edison had to solve one more problem to make a useful light bulb. He knew that things need oxygen to burn. He predicted that if he could remove the air from the glass globe, there would be no oxygen, and the filament would not burn up. He was right. This new light bulb lasted months instead of days. Thomas Edison had seen the light. Now it was time to show this new light source to the world. It was New Year's Eve in 1879. Edison's team strung lights from their lab to the train station. A crowd of more than 3,000 people came to see what would happen. It was a very dark night, and all the gas lights had been turned off. Edison stepped up to the platform and threw the switch. All the lights came on. The crowd cheered. Edison understood the importance of electric lighting. It could change the American way of life. That's why he asked Latimer to join his team in 1884. Latimer stayed with Edison for years. He wrote patents for new inventions and books on electrical engineering. 2 more pages to go. Many years later, in 1918, the team of scientists and engineers gathered to celebrate Edison's birthday. They called themselves the Edison Pioneers. Lewis Latimer was the only African American among the engineers. He was also one of the 28 founding pioneers. Light bulbs today. In Edison's time, the only way known to make electric light was to make a filament so hot that it glowed. The glowing filament gave off a lot of heat and a good amount of light. It takes a lot of energy to make light by heating a filament. Today we have alternative ways to make light that don't need nearly as much energy. The long white tubes that produce light are called fluorescent lamps. A fluorescent lamp does not have a filament. Instead, the tube is filled with gas. When an electric current travels to the light bulb, the gas begins to glow and give off light. The light is not quite as bright as an incandescent lamp, but the amount of energy needed to produce the light is far less than the energy needed to heat a filament. In this photo, you can see the Edison pioneers, including Lewis Latimer, the only African American among the engineers. Moving on to the very last page. We also have compact fluorescent light bulbs. The tube is much thinner, and it's wound into a coil to save space. Compact fluorescent light bulbs screw into standard sockets designed for incandescent light bulbs. Replacing all of your incandescent light bulbs with compact fluorescent light bulbs can save a household several $100s every year. In 1962, a new light-producing technology was developed. It was a tiny device called a light-emitting diode, LED. I'm sure some of you are interested in that. LEDs produce light by using a small amount of energy to emit a ray of light. The LED doesn't waste energy by producing heat. The first LEDs were dim and produced only red light, but they were extremely efficient. As electrical engineers continued to develop new LEDs, they developed amber and green colored LEDs. The colored lights made it possible to convert traffic lights to LEDs. This saved cities a lot of money. Eventually, an LED was developed that produced pure, bright, white light. The newest technology for lighting homes and businesses is LED lighting because modern LEDs can produce bright, white light using much less electricity, resulting in huge cost savings. You might have seen flashlights that use clusters of small bright lights instead of a single light bulb. Those small bright lights are modern LEDs. So guys, I sent these questions in the agenda, but if you would like to take a photo of this right now, here are the questions for today. Number 1, how do you know when energy is moving in a light bulb circuit? Forgot? Go back and watch the movie again. Pause it so you can hear the reading. 2, describe the path taken by electricity through an incandescent light bulb. And number 3, what are some of the reasons why lamp technology has changed? Any questions? Please give me a call or send me a message. Over and out.